Graders, welcome back. We're going to do 5.3, example 3. We're going to continue with elimination, that strategy for solving linear equations, and we're going to use multiplication first. You use multiplication if none of your variables have either the same number or opposite numbers in front of it. So as you look at letter A here, you see the number 2 is in front of x, but there's a -1 in front of the x underneath. There's a 1y and a 3y. So we don't have the same number, we don't have opposite numbers, so we got to have a way to still do elimination, and there is a way to do it. Okay, first thing you've got to decide is, which variable would you like to eliminate? It doesn't matter. I'm actually going to show you 2 ways to do this problem, 2 possibilities out of endless possibilities. You may want to have some scratch paper nearby, some notebook paper, because I think I'm going to run out of room. So if you want to pause me for just a second, go grab some extra notebook paper, and I just want to make sure you have plenty of room for taking notes, okay? All right, hopefully you've got your notebook paper, and we're going to go ahead and get started. I'm going to rewrite this, and first time through, I'm going to work on eliminating the x's, okay? So as I look at the 2 numbers, I'm studying them and I'm going, well, my numbers are 2 and -1. Now, if those were denominators in a fraction, what would be the common denominator? And if you were thinking, hey, I would want to make those both 2, you would be absolutely right, okay? That is our goal. Now, I'm going to leave the top equation, leave that alone. I already have a 2 in front of the x. I'm happy with that. It's the bottom one I want to adjust, okay? So put parentheses around it, because what we're going to have to do is we're going to have to multiply the entire equation by a number. And since -1 is already negative, then wouldn't it be cool if I made the x up top, left that as +2, and I made the number underneath, I made -1, turned it into a -2. Now, how would I accomplish that? Well, what number times -1 will give me -2? And hopefully you are saying to yourself, +2. You're exactly right. So we're going to literally distribute that to every number in the equation. I can't just do it to the first number and not to the rest of them. I've got to do it to every number in the equation, okay? So let's go ahead and do that. 2 times -1x is -2x, 2 times 3y is 6y, and 2 times -12 is -24. And then I'm going to bring that other equation that I don't want to adjust, I'm just going to bring that down, align it, and then I'm ready to decide whether I add or subtract. Notice right here, they're opposite numbers. Opposites always add up to be 0. So I need to add these numbers. That's how you get rid of the x terms. So let's do 6y plus 1y, that's 7y. And -24 plus 3 is -21. Then divide each side by 7. And we've got y is -3. Perfect. Beautiful. Couldn't ask for better. So then you just need to go back up to the original equations and make a decision. Which equation do you want to plug into? Well, 2x plus y equals 3 looks good to me, so I'm going to take that -3 and I'm going to plug it in for y. 2x plus -3 equals 3. So now I'm going to add 3. I've got 2x equals 6. And then divide each side by 2. Oh, that's wonderful. X is 3. So you know what? Our point of intersection is 3, -3. And that's elimination. And that's if we chose to get rid of the x's. So grab your notebook paper. I'm going to erase. You don't erase. I'm going to erase because I need a little bit of space here. And let's go back through. Let's do the problem again, but this time let's eliminate the y's. Now notice that we have a 3y and we have a 1y. Now if these were denominators, what would the common denominator be if my choices were 1 and 3? Now hopefully you said, hey, the common denominator would be 3. You're exactly right. So I want to make it so that this top equation has 3y in it. The only way to do that is to multiply that entire equation by 3. Now, why is that? Well, what's 3 times 1? Remember, the y has an understood 1 in front of it. 3 times 1 will give me the 3 that I'm seeking. Okay? So let's distribute. All right, there we go. We got 6x plus 3y equals 9. So there's the distributed view. That's with me distributing 3 to that top equation. Now I'm going to bring the other equation underneath it. So I've got negative x plus 3y is equal to negative 12. Awesome. And now we just have to make a decision. We got 3's, positive 3 in both in front of those y's there. And when they're the same, remember you have to subtract. So we need to subtract. I'm going to make a big heavy subtraction mark there to remind you we are subtracting. So don't get caught up with the signs, okay? Don't let those trip you up. Remember we got 6 minus negative 1. Remember that's a negative 1 in front of that x. That's actually 6 plus 1, which is 7x. 3 minus 3, 0. Those are going to cancel out. Drop down your equal sign. 9 minus a negative 12 is the same thing as 9 plus 12, which is 21. Divide by 7, and we've got x equals 3. Great job. So now we just need to pick an equation. I'll go with the top one. Now we're going to plug in 3 for the x. 2 times 3 plus y is equal to 3. That's 6 plus y. Take away 6. And I've got y is negative 3. That's wonderful. And so my point of intersection is 3, negative 3. Now look at your notes. Is that the same answer that I did the first time when I eliminated the x's? Absolutely. My point is, it doesn't matter which one you choose to get rid of. You should get the same exact answer regardless of which variable you get rid of. Okay? You can always take 3 and negative 3, plug 3 in for the x, negative 3 in for the y, and test it out, make sure it works. You can always check to be sure. Okay, let's look at B. B, we're going to have to adjust both equations, okay? So I've got a 7 in front of the x, a 5 in front of the x. I could, if those were my two denominators, if they were denominators, what would be the lowest common denominator of those two numbers? Yeah, I could turn them both into 35. How about the y's? I got negative 12 and negative 8. Well, as I'm kind of going through my mind, I could make them both negative 24. Could. I mean, that's a possibility. So it's just up to you. You can eliminate either one. It doesn't matter. I'm going to do the y's, okay? I'm going to focus on the y's. And so I want to make y negative 24. So I'm going to have to multiply by 2. And then on the bottom equation, I'm going to have to multiply by 3. That'll give me my negative 24. So that's good enough for me. So make sure you distribute. You have to multiply to every term. So that's 14x minus 24y equals negative 44. Go back and do the same thing with the 3. Awesome. So that's 15x minus 24y equals, what's that, negative 42. Okay, now remember when you have the same sign, we have negative 24 in front of our y's there, got to subtract. So I'm going to make a big, heavy, dark mark to remind you to subtract. So 14x minus 15x is negative 1x. So be real careful, it is a negative 1, it's not positive 1. The y's cancel, drop down your equal sign, and negative 44 minus a negative 42. If you're not seeing it, off to the side, just jot it out so you can go, oh yeah, 2 negative signs in a row, going to cancel out. Negative 44 plus 42 is actually negative 2. And then divide each side by negative 1. And you've got x is equal to positive 2. Halfway there, just pick one of them you want to plug into. I'll take that top one. That's fine. It doesn't matter. You choose whatever looks easier to you. And plug in. And we've got 7 times 2 minus 12 times y equals negative 22. Remember, 7 times 2 is 14. And then from here, it's a 2-step equation. So we're going to take away 14 from each side. and I've got negative 12y is equal to negative 36. Divide each side by negative 12, and I've got y is 3. So my point of intersection appears to be 2, 3. Okay? Could I have eliminated the x's instead? Yeah, I could have. I still would have gotten 2, 3. It doesn't matter which variable I started with to eliminate or chose to eliminate. So there you go, guys. Now if you flip to that next page, I'm giving you not 1, but 2 extra credit opportunities, okay? So I want you to try these. This is for extra credit. I'm going to be checking these tomorrow and seeing how accurate you are. So good luck with that. Please bring any questions you have to class.